All right, so we last time we talked about mitigation measures at the building level, and this includes using flood barriers, using water pumps, elevating water sensitive components, or using combination of these mitigation measures. But we didn't talk about community level mitigation measures. Like what mitigation measures that the city can do to mitigate the flood impacts on the entire community. We're talking about household mitigation measure. We are assuming that the household is cooperative and he's willing to protect his house and is gonna have a flood barrier built around his home and he's not gonna run away from the flooding. And this rarely happens. Most of the people, especially the wealthy people, like if we're talking about Hurricane Ian, where it hits most of the luxury expensive homes, they just run away. When the hurricane happens, they run from the west coast to the east coast, and once the event is gone, they go back to their homes and see what happens because they value their life. Okay, whatever it happens, I will go and replace and do whatever. However, there's some people doesn't have any options. They will just stay at their homes and they will protect it. That's why we did the 10%, 20%, 30% of the population are doing flood mitigation measures. But today we are going to talk about, and this you are going to apply in your project. And this is like a small task. So what is this? A small task is, what if we did community level mitigation measures? What comes in your thoughts if we are talking about community level mitigation measures? What we can do at the community level that can enhance the flood resilience of the community or can reduce the flood losses of the community? What do you think that we can do? Actually, we talked about this in the first couple lectures about mitigation measures at the community level for flooding. Do you remember any of these? Levies. What was that?
Like we will have to reduce their vulnerability and exposure. So
yeah, we already reviewed and they are vulnerable. What mitigation measures that we are going to do? It would say levies. Levies is one of the main elements that you can build in a community, but it to reduce the flood risk or to reduce the flood vulnerability. But it comes with cost, and also where are you going to put this levies?
if you do that, if you use levies, don't you move the problem to another community?
It depends.
Yeah, it depends on how you put the levies,
That's
of course.
why you need to study. That's why we say, I will come to this later, but levies is one of the solutions. The water had to go somewhere. Yeah, you put levees, but the water will accumulate behind the levees and might flood other communities. That's what we want to see. Maybe it will not flood other communities. Maybe it will go to a big swamp or it goes to like a very wide land. So the water will go somewhere, but this is what we need to investigate. If the levee is gonna flood other communities or not, right? So levees is one solution. What other solutions that we can do? So other solutions is that you can build dikes like dams, small dams, or what we call maybe floodgates to regulate the water. Like you can retain the water behind the gate and release the water with a specific amount of flow that doesn't overflow the downstream. Okay, so this is one of the solutions. One of the main or maybe the best solution is to build retention systems. So retention system is kind of like you are building a lake. So you come to a very open land, clear land, doesn't have buildings, or maybe few amount of buildings, and you pay these the occupants of these buildings, and you like do acquisition for these buildings and use this land to build a retention system. You go bring all the machines and dig this land with a specific level and make some channels to connect the water from the city to this land. So what we do is we do a retention system, or we called it retention pond. This retention pond will have the water for a specific amount of time. Like it will take the excessive water that are gonna flood the downstream. And once this is getting filled up, you can regulate the flow out of this retention system in a way. So our problem is not of having water. Our problem is the flow of the water. You just to get suddenly a 10 time or 20 time of the flow that this river can have in a specific amount of time, like in few hours. So what we do, we take this overflow in the retention system and reduce the flow in the river so that it doesn't flood the downstream. And once the flow gets back to normal, we keep getting the water outside this retention system, like one by one, like maybe a few cubic water, like a few flow, like step by step until you can drain, or maybe you can have some water inside this. So it's kind of lake. You are building a lake. So this is one of the main systems. So what I want to do in your project is that I have a bunch of scenarios. Each one of you we're gonna investigate only one scenario, and I'm gonna provide you the hazard map. So I will send you the hazard map. Before this, all the mitigation measures that I talked about, either levees or either floodgates or either retention system. So what we are changing in the risk component, like, are we changing the hazard? Are we changing the exposure of the building? Or are we changing some building characteristics? Like, for example, what we did with a flood barrier or a water pumps, we are doing something at the building level. We are decreasing. So when we did the barrier, so we are decreasing the vulnerability, like we played in the fragility, right? So that's what we did. So we did something in the building, played with the fragility. So we changed the vulnerability of the building, okay? Pumps is the same way, like you brought a pump and this pump is taking the water, and then we did it at the building level. So we decreased the building vulnerability. But bumps also can be considered as decreasing a hazard, but we didn't consider this because it was locally, like a very small bump taking the water from the building. So we are doing something at the building level. So we are changing a vulnerability of a specific building. But what we are talking about right now, building a levee, so it will change the hazard map. So if you have a levee at some place, this levee is gonna like redirect the water to a different place. So your hazard map will be completely different. Same thing, building a retention system, you are decreasing the flood depths in your areas. So you are decreasing the hazard. You didn't do anything to the buildings. You didn't do anything to the exposure of the buildings or the vulnerability of the buildings. So it's all about the hazard, right? So we need to remodel the hazard map. So we need to develop another HICRAS model that takes into account that there is a levee in a specific place. And once the water is flowing in your HICRAS and touch the levee, it will reroute in a different direction, right? Same thing with a retention system. You have a water, this water is hitting the river, and the river is connected to a channel, and the channel goes all the way to the retention system. So once the water reaches a specific level, this channel is going to take the water to the retention system so that it can regulate the water flow in the downstream. I want to show you how these mitigation measures work, and like I used to have a video. Let me show you one moment here. Okay, I only have one video. All right, let me show this to you. And I think you guys have seen that before, but let me show it one more time. Oh. I don't know what happened, but maybe it's very heavy. Be displayed. Okay, let me display. Oh, it's just a picture, it's not a video. All right, but anyway, let me open it in the publication. Let me close this because it will slow down the whole thing. All right, let me show it very quick. All right, so this is Lumberton, and this is the hazard map after we build a levee. But this is after many trials to find the optimal elevation of the levee. So here's the first part of the levee, and this is a second part, and this is a third part, and the force part. So it's a levee that has different elevations. So I divided it into different parts so that I can come up with the optimal combination of elevations for these 4 segments, because the levees, if you kept putting material, will cost you a lot. So you want to come up with what is the optimal elevation that can protect your city and reducing the amount of cost. So I believe I did like 5 or 10 trials to come up with the best combination. So I know that there's a roadway embankment. So actually roadways work as levees, because usually roadways is kind of like have embankment and then you have the roadway. So usually when the water hit the roadway is kind of a levee. But what we are considering here is that to build either a levee here at this location, like adjacent to the road, or increasing the road elevation at this location. Here and all over there. This is the ground level, the black line, the one that you see for this part. How does the ground look like at this location? And this is the ground level here at this part. Because here there's a bridge. So you can see like the ground is something like this, and then jump off when you go towards the bridge at the underpass. Like you guys remember, we have an underpass here between a railroad and also the highway, and this is what let the water in. And this is the other one, and which looks something like this. So what I did is I assumed that I'm gonna have a levee that has a constant elevation, this elevation, at this part and this part. This part, I'm gonna have this levee that has multiple steps, something like this. And I could try different elevation, different top elevation of these levees. Like here, for example, I'm going to show you a table that shows I did some scenarios. So I did like 28 mitigation scenario. Number 0 is the scenario without any mitigation. If you see, like I have crossed in all these mitigation measures. There is no floodgate, there is no retention system, there is no building acquisition, no building elevation, no levee enhancement. So there's nothing. And the second one, I only have a floodgate, and I did the simulation for one reason. This reason is, the thing is with levee, whatever levees that you build, if you still have this gap, all the water will accumulate behind this levee and then go all the way around and then overflow from this gap. So first you need to fill this gap. Don't allow this gap to get water inside your city, because whatever levee enhancement that you have, because we already have a levee, we already have this levee, it's filled, but the problem was this levee has a gap. Yeah, all the water goes behind, but then the water tears away and then come from this gap. Okay, so I tried, how about with the current situation, if we build a gate, and this is actually what the city of Lumberton is working on right now. They are building a hydraulic gate here, so when they have flooding, they close the gate, and once the flooding is gone, they open the gate so that the road can go in its best. So actually, they are building this gate right now, because every time they have a flooding alarm, the emergency management orders to build a temporary barrier system. They go and drop sands and gravels and sandbags, and they build like a temporary barrier. But this is not efficient, because in Hurricane Dorian, they did the same thing and there's no flooding happen. So they waste lots of money. Okay. All right. So I tried a gate without any flood mitigation, or without any other flood mitigation, like only flood gate without any enhancement to the levee system. You know what happened? The water kept accumulating behind this gate. It is very strong and it's working very well. Because here's the road, you have a bridge, and here's you have a road. So it goes all over the bridge, and then the cars goes down there. The thing is, the gate closed the gap in this bridge. The water kept accumulating behind the gates and goes all the way around and overflow from here. Let's see what happened. Here, can you see what happened? I built the gate here. This gate doesn't allow any water to come around, and it has a higher elevation. So what happened? The water overflow over the side from the gate because the water had to go somewhere. This is the answer for your question, Claudia. So you're asking about, okay, I'm gonna do a mitigation measure, but it's gonna flood. So that's why we need to try and see if it work or not work. We build a gate and then the water overflow from other side here. Can you see? And then, you know what? The amount of losses that triggered by this gate was more than if you didn't build a gate. Because the thing is, the water overflow is much higher depth because the water kept accumulating and then finally everything's broke because you kept restraining the water and finally everything's broke. So you are having a lot amount of water that is with much higher velocity is coming and damaging your community, right? So that's what happened with gate. So that means like, and this is proves that one mitigation measure is not gonna work. You will always need a combination of mitigation measures that can take the water peacefully and safely without causing any damage. So we need to build something with this gate. So enhancing a levee system without this gate, it will be useless because whatever enhancement that you did to your levee, so all the water will come around. And also levee alone is not gonna help because levee is gonna protect the water at some point. Levees can, like the floodgate can work if you have a small scenario, like a small maybe 50-year, but if you have a really big scenario, it will not work. And this comes to the rule is when you design a mitigation system for a community, you need to ask the community, what is the return period that you want to design this gate for, or what the return period, because this gate is gonna work maybe for 50-year or 100-year, but if you were hit by a 500-year event, it will not gonna work. So this is the very question that you need to ask if you want to design a mitigation system for a community. Even if you build a gate and also do this enhancement to the levees, it can resist, but it depends on what is the return period that you are designing your system for. So if you are designing for a 500-year, so you will need this level of elevation for the levees. But if you need more, like if you need like to design for a 1,000-year, so you need much higher elevation. But at anyhow, like this community can fail even whatever system that you did if it hit was like a 2,000-year event or a 3,000-year event. Okay. So this is the point from like the mitigation system. Like here, I was also looking at different levee heights. So if you can see, this is scenario number A, scenario number 0, 2, 3, 4, 5, 6. Okay. So this was some levee enhancement. I believe this is, yeah, either the levee enhancement or with gates. And then if I did more levee enhancement, like increase the elevation of the levee, can you see there is no much difference between them? Like maybe this is the problem. Maybe you do some levee enhancement and it doesn't do anything because you need more. See here, I did some levee enhancement and actually caused a huge amount of flood reduction, just a few amount of water. You see like this light blue, actually the height of the water here in this area is like around 6 inches, which could be in the street. So actually I can go with that. Like I can allow the water in the street with 6 inches, but if you increase the levee elevation, so you end up with having a almost full protection for your community. There is no drop of water in South Lumberton here. Increasing more, if you can see, here I have some water overflow, but if I increase more, you have completely full protection for this area. Because you increase the levee height here, and the levee height here, and you build a floodgate here, and you increase the levee height all around here. So you provide a full protection. And this will come to the question that Claudia asked. Okay, you built the levee, but you might flood other communities, and that's actually what happened. So with this levee height, I didn't have any problem with people living here, but I increased the height a little more. Did you see what happened over there? The water backed up and flooded other communities. Okay, and to be honest, this actually reached community. Like the poor community lived here in the floodplain. The rich community lived here, like the houses here. I visited Lumberton. It's like in millions of dollars, like each house, like 4 million, 5 million. It's really expensive houses. So what happens here, I got some buildings flooded here. But the number of buildings that got flooded from such protection was like around 50 buildings here. but we protected 2,400 buildings down there, so that's why we need to choose. So doing one mitigation measure is not enough, so you have to look at other solution so that for this community. So you can offer for this community to buy out their homes, like the city or whatever the mitigation agency that working on that. You have like 50 home, each home is like $1 million, you offer $1 million for each one of them and buy their homes. If it's expensive, okay, how about elevating the homes so that they can survive whatever level of flooding that they will have? So right now we are considering building a levee, building a floodgate, and a combination of buyout building and elevating buildings from the ground. So 4 mitigation measures at the same time. That's why one mitigation action is not enough. We need to look at other solutions.
I don't know how like that buying out things work here, but for example, like here I'm in the States. But for example, in my country, you can tell the people to move, buy their homes, but they will still
Same
do
here.
things in vulnerable places. That's the
Same
problem.
here.
How do you mitigate that?
Same here. You cannot force people to sell out their home, but they will be on their own risk. The city has the right to build whatever mitigation measure, but you are telling them you will be at high risk. So I'm offering you to buy your home. Are you willing to sell your home or not? So that's the thing. Also, there's some mitigation measure, maybe building this levee is gonna cost $100 million. So maybe the city will consider, how about if we buy most of the vulnerable homes here? If the cost of their homes is less than $100 million. So this is also one of the solutions.
Build something that puts them in danger.
They can sue that, but actually you are protecting, so you have a plan. So you have a plan to protect the community. So they can sue you and everyone can go to the court. It will be difficult. There's nothing easy. So yeah, this can
People
happen.
sue you for everything.
Hmm?
People sue for
Yeah, yeah, yeah.
everything in
Yeah.
this country.
The city will get a lawyer and they will get a lawyer and it will be like this, but everyone should have a mitigation. Maybe they will build and they will not communicate the risk with other people. We are gonna build this to protect this. These people is not gonna figure out that this is gonna increase their flood until they get flooded, so. This is one way, because the water has to go somewhere, but what can solve all this issue? Because here, the water didn't go here. But if you look, I need you to look at this flood. At the color over there, like the main one. Oh, I'm not sure where it is, but actually, if you look, you will find that the blue color here is much darker. As more as the levee height is getting hot, is getting more, because more water is squeezed in are forced to move in the riverbed, right? So the water, that means that the water needs to go somewhere. Here it goes, yeah, in the past, but also flooded some other building with a very few amount of water, like all this light blue is like maybe maximum is 1 feet of flood. Maybe they will not get flooded if they are a little bit have elevation. But the solution that can solve this is to build something that can take the water in and then discharge this water once the event is gone. So let me show you some result about this. Something like this. Like to build like a water tank, but it's not a tank. It's like an open area, like a lake. And then somehow you are taking the water from here and delivering to this place. But actually, the bones shouldn't be like this way. They have like a shape that can fit the topography. There's a shape optimization that can have a low amount of cutting and filling and all this stuff. But I was just doing this hypothetically. I just want a container that can take amount of water of the stream, whatever are gonna decide where this is gonna be. Maybe it will be here, because it can be much cheaper if I move it here, because like this land is much lower than this land. But I wasn't thinking about where it should be more than I need the water to go somewhere and see how this is gonna impact the flood. But at some point I figure out, okay, so how about if we figure out different places? The thing is, when I put the retention system here, I had to remove like around 100 buildings from this location. So we need to force 100 people to leave their homes so that we can build this big retention system and take the water in. And I was considering a much bigger retention system. How if we have this big retention system and we need to move out 300 buildings from here, like to buy them out. So this, at the same location, I investigated 2 different volumes, water, But what if we change the location? So the good thing about this location, it takes the water from both branches, from Red Spring Creek and also from Lumber River. But I know that Lumber River is the biggest, so I tried to see what if I built a retention system just close to Lumber River. And once that, can you see how much the flow here? The water has a high depth, and once the water entered at this location, it takes the water inside here, and then the amount of water gets very low. But can you see something in this retention system? The water came here and it's dark blue here, but it overflow and allows some water to goes out of this retention system. Okay, so I tried different bed level for each one of these. This has the much like it was like shallow, and this is more deep. Sorry, this is the more deep one because all this water came in, and actually the amount of water is coming out of this retention system is not that much. Like I can say like it was like 6 inches, 1 feet maximum, but I increased the size, but not the area. I increased the depth. I took more water, so I got less water outflow from this, and I increased one more. So it needs to be increased a little bit more so that it can take all the amount of water. So I tried different volumes of the retention system, different location of the retention system. So I want to ask you, how can I model a retention system in HICRAS? What the first thing come to your mind? How to do it? It's very simple. Even you can do it not in HICRAS.
Can make it in ArcGIS, like, area with that. Will that?
Exactly. So we created in the DEM model. Yeah, that's it. Excellent. So basically you have the digital elevation map. You can, what I did, I made a polygon that has like this oval shape and a rectangle here, and I give them an elevation. This elevation is the bed level of the retention system. So this is a polygon, and I converted the polygon into a raster. And this raster value, it has only one raster value, which is the new elevation of the retention system. And I merged the digital elevation map of the ground with this raster of the polygon. And I created this in the topography itself. And I give this to HICRAS as an input. I run the analysis. I did the same thing that we did in our class, but with different them, all of these scenarios. Okay, so that's what I did. For the levy, there's an option, it's called like weir for this one. And I draw a weir. This weir is kind of like a levy. And this weir, you only draw a line. And for this line, you give HICRAS that the top elevation of this line is this value. And that's it. So it's basically the same HICRAS model that you developed for your homework, but you just draw a line at this levy location and tell HICRAS that this line has this elevation. Like drawing a break line, it's like the same concept. You draw a line or a weir, and then you give the weir like it's say, and you can actually divide it into elements. Like you can say that this one has this level and this one has this level. It's very simple. And you run the same model. So I didn't do anything complicated at all. So it was very easy. Okay, so let's see how can you do this? How can you rerun your risk analysis, the same analysis that you did for your project? I'm gonna give you a raster map. Each one of you will have a different scenario. Like, for example, I'm gonna give you let's say one of you will take scenario number, this scenario number 5, where you have a levy. Some of you will take a scenario that you have a retention system. So I will give you the hazard map with retention system. So you will not need to do any HICRAS models. Each one of you will get one. So what do you think you are gonna done different than the base flood loss analysis that you have done before with this? What is different? What the steps that you are gonna do to get the damage for each one of these buildings?
Number of buildings.
Yeah, so first you need to identify what buildings that are exposed to the new hazard. It's the same hazard, but with mitigation. Okay, so you will have to extract these buildings. Can you see? I extracted one. Let me see. This is scenario number 5. Let's see what scenario number 5's building look like. Yeah, here. So these are the buildings. All right. We have more. Scenario. Okay, I have 2 scenarios shown here. Let me. This is scenario number 9. Okay, yeah, that's right. Yeah, here, can you see this buildings? These are the buildings are within the flood hazard map in scenario number 9. So you have all the buildings in your community, and you have the new scenario that I'm gonna give to you. So you will extract only the buildings that are exposed to this scenario. The same thing that you did for the baseline damage analysis, like you have a hazard map and you have a building, you extract only the buildings that are exposed to the hazard. You will do the same thing here, except it's a different hazard map. What was that? Which mitigation measure is that? Oh, this is not this is Hurricane Matthew. And I run Hurricane Matthew with some mitigation measures. So I'm gonna give you this. So you can call it Hurricane Matthew with a retention system. Something like this. All right, so I have the hazard maps and then you have the buildings. What are you gonna do next? What are you gonna do next is that you are gonna subtract the new flood level at each one of these buildings. You will calculate the flood depths measured from the ground and the flood depths measured from the vertical floor elevation. You need to have these, and you will run the same MATLAB code that you have from before. So you will do all the work in ArcGIS. I'm gonna give you the hazard, and you already have the buildings. We'll do 2 steps. First step is to identify which buildings are exposed. The second step, you extract the flood depths of each building. That's it. It's done, and then you take the new shapefile in the MATLAB code that you have and exchange the shapefile name and rerun the code, and it'll tell you what is the damage, what is the building's damage rate. Is that clear? Is it difficult? Okay. So basically you'll have something, let me do it here. So what you will have here, for example, we are talking about scenario number 9. We have all the buildings. So I have here the building polygons. First, I will convert these polygons to points. Then I will search a tool without searching, actually. Let's get the tool, spatial analyst tool. Search. Feature point. And then I will take the building polygons and put them here. All right, and then I will say, okay. Then close. Okay, so right now I converted them to points. So let's work with scenario. Okay, let's do. We have 6. Let's do 9. So for 9, what I do is I will go to spatial analyst tools and the spatial analyst tools, extract multi-values to points, And I'm gonna pick this input feature, and I'm gonna pick this raster map, and I will name this, for example, scenario 9. Okay, depth scenario 9. I'll say okay. And then right now, if I open this shapefile, I will find in the last column, what is the flood depths at each building? You will find most of the buildings has null, like they don't have any flood depths. Why? Because they are not exposed to flooding. So just a few of them. Let's see how many of them. You have some here. Okay, see, we have some buildings has 19. Let me see what is the, I think this flood hazard map has the flood depths in foot. Yeah, so has 19-foot flood depths. Do you know where are these buildings? The one here. Because these needs to be removed, right? Because I will never be able to build a detention system until I ask these people, but I'm just putting a hypothetical location and see. So you have a bunch of buildings that has 19 and 17 flood depths, which I believe they are here. Let's see. Okay, so if I selected these buildings, yeah, can you see a bunch of them here and a bunch of them there? But anyway, let's select the buildings that has flood depths more than 0. Like I say, the depths coming from scenario number 9, and I'm only interested for the flood depths are more than 0. So if I click apply, I have 2,251 buildings. I will take these buildings alone and export them. So what I will do is I will click here, data, export data, and only selected feature, and I export this data. Okay, so I will have these, but just name them like what I did here. So what I named them like scenario number 1, scenario number 0 is just for organizing. But I'm just doing this just to explain to you. All right, so let's see what we have here. I have only 2,251 buildings. And I have the flood depths at each one of these buildings in foot. So, but I believe, yeah, I will send you these hazard maps and it will be in foot. It's not in meter. I will tell you what is the unit if I will convert it for you, but it's very easy. If you want to convert a hazard map, there's like if you have a raster map in meter and you want to convert it to foot, there's something is called raster calculator. This one. You basically put the raster map here. Oh, not this one. I'm saying raster. This one. You basically select whatever raster that you have, maybe this one, and you multiply it if it's in feet. So you multiply by the conversion from feet to meter. If it's in meter, you multiply by the conversion from meter to feet. So it's very easy. But anyway, I prefer to do this in the attribute table because this is what I'm gonna do. Like if you extract the value at each point and it's in feet and you want to convert it to meter, when you do the extraction, multiply by the conversion. It's the same thing. All right, so I have the flood depths is here. So you will go back to your MATLAB code and rerun the MATLAB code using this value. But before you do this, this is the flood depths measured from where? From the ground or from the verse floor elevation? From the ground, because the raster map is from the ground. So this flood elevation is from the ground. We want another one measured from the verse floor elevation. What we should do? Does any of you know? How can I do it?
The water surface elevation.
How can I get the water surface elevation? Actually, oh yeah, you can get that water surface elevation directly from HICREST, but right now I'm outside HICREST. How can I do it? What was that? So we need the ground elevation hazard, the ground elevation, the digital elevation model, right? So let me go grab the digital elevation model very quick. Train. The ground elevation model, I give it to you for the homework number 5 to do it for HERCAS, and this is the digital elevation map. I will drop it here at ArcGIS and put it here. This ground elevation is in meter. Just be careful. So what I'm gonna do, I'm gonna do another extraction, multi-value 2 points for this one. And I'm gonna ask ArcGIS to give me the ground elevation in meter for each building. And I'm gonna say, okay. If I close this and reopen it one more time of an attribute table. So right now I have 2 things. The flood depths measured from the ground and the ground elevation. So if this is my building and this is the ground, what I did right now, I got the ground elevation in meter, and I have the flood depths measured from the ground, coming from scenario, that's SC9. SC9, this one. The ground elevation is a big number. Why? Because it's elevation measured from the sea level. But this is a small number because it's absolute number measured from the ground. Okay, so if you want the water surface elevation, you basically sum the ground elevation plus the flood depths that coming from scenario number 9. Make sure that you did unit conversion because you have the ground elevation is in meter and you have the values from scenario 9 is in feet. So be careful about the units. And what I came up with here is the water surface elevation. And then you get it either in meter or feet, but just be consistent. Okay, so why I'm doing this? I'm doing this because I want to measure the flood depths from the FFE. So to do this, I need to get the water surface elevation. And then to get this, and to get the flood depths FFE coming from scenario number 9 should be equal to the water surface elevation minus the various floor elevation. And then we have this one. You guys understand this? Okay, so right now, I need to calculate 2 values for MATLAB. Let's write them. The first value is the flood depths. I will name it FD. Measured from the ground elevation, I'm gonna name it GE in meters because our functions are all in meters. So we need to be consistent with meter. And this is gonna be a double. And also I'm gonna define another one, which is the flood depths measured from the first floor elevation in meter, and it's also gonna be double. This is the 2 values that I need for my MATLAB code. Okay, so here, what is the value of this one? This is directly is the depths that we measured from the raster map of the scenarios. So the flood depths measured from the ground elevation is basically this one. All right. Let's remove this one because this is the hazard map. The blue one, the coming from depths of scenario 9 is the flood depths measured from the ground elevation. I just give it another name, a different name. This one we have to write a function. Okay, to write this function, let's see what we are gonna do. All right, so I'm gonna do a field calculator here. Just focus with me here. Verse floor measured from FFE is equal to water surface elevation minus the FFE. But the water surface elevation has an equation, which is the ground elevation plus the flood depths measured from scenario 9, and this will be minus FA. Okay, so let's do this. Ground elevation. I'm gonna put ground elevation here. And the ground elevation is in meters, so I don't have a problem with the ground elevation. So I'm gonna put on the top of the ground elevation, the water depths measured from the ground, which is depths scenario 9. And I'm gonna multiply this by the conversion from feet to meter, which is 0.3048, right? And then all these, I'm gonna make minus the VersaFloor elevation. And the VersaFloor elevation is in feet. So I'm gonna multiply this also by 0.3048 to convert. Then I'm gonna say, okay. Okay, so right now, do you guys have any problem with the function that I just wrote? Is it difficult? I just substitute with this. I got the ground elevation in meter, and I have the flood depths measured from the ground, but it was in feet, so I multiplied by 0.3. And I subtract the level of FFE, and it was in feet, so I also multiplied by the conversion. I just did this 3. So what I did, how did I get this? I have 2 rasters. One of them gave me this one. I got it from the digital elevation map of the study area. And this one, I got it from the hazard map from HECRAS, which I'm gonna get to you. This will be given. This is in feet. This is in meter. So I need to multiply this by a conversion 0.3048. This one is in the shape file. The verse floor elevation is a value for each building. So this is also in feet. So you will have to multiply by 0.3048. Okay. And then I got all this information. It gives me the flood depths measured from FFE. Why did I get a negative value? However, I made sure when I extracted all these values, I made sure I had a positive values. Like I made sure that every building is exposed to flooding. You guys remember when we extracted the buildings that has flood depths more than 0? So these values, the flood depths measured from the ground is more than 0. So I'm only selecting the buildings that has flood depths. Why, when I did flood depths measured from the verse floor elevation, I got some negative value? You guys have any explanation? Because some buildings have verse floor elevation that is much more the flood depth height. So you can have, at some locations, you can have the water level here. So if you subtract this minus this, sorry, if you subtract this minus this, it's gonna give you a negative value. So that means that there is a buildings are exposed to flooding, but don't have any damage because the verse floor elevation is more than the water surface elevation. However, the water surface elevation is more than the ground elevation. Okay.
It should be either type 1 or 3, right?
It will matters when you have archetype 1 or 3.
No, I mean like if it's not a type 1 or 3, they should not be.
If it's archetype 3, it will be measured from the ground. It won't matter.
Yeah, that's why I'm saying like if I get like a first floor renovation, not that's from first floor renovation negative.
You make it 0.
No, I don't mean, yeah, we made the 0 for archetype for every archetype except 1 and 3. This one should be either 1 or 3. I think.
No. This is agnostic. Doesn't have. We didn't look if this archetype is 1 or 3. We did it for all the building, and then we are gonna figure it out if this are type 1 or 3 or not. But for 1 and 3, we are only interested for buildings that like for 1 and 3, we are interested like to see the water depth measured from the ground. So we are not gonna use this one. So this is not an issue for archetype 1 and 3, because we use this, the flood depth measured from the ground elevation from here. Because the thing is, most of the people use this area to store things, to have ductworks, and that's what I assumed in my model. So I assumed some components here. So if I started the damage from this level, I'm ignoring everything here. So that's why I made my archetype goes from 0. That's why also when you develop archetype for coastal buildings that are elevated by 1 story, usually this is not empty. People have something in this 1 story. They have like a storage, they have a garage, they have something. So it has to start from the ground, okay? So for archetype 1 and 3, I'm starting from the ground elevation. So I'm not looking at this, adverse floor elevation flood depths. I'm looking at that, right? But the thing is, for other archetypes, I'm looking at this one. And if it's a negative, so I make it 0. So all these negatives, I can make it 0, because if it's below this first floor elevation, so what? You don't need that. Okay, so let's make these negative 0. So basically you can select here the flood depths that is more than, sorry, that is less than 0, which means negative, and say apply. So we have like 791 buildings that are 0, and then I'm gonna isolate them and make their values equal to 0. You can make it either in ArcGIS, or you can take it to MATLAB, and then when you come to MATLAB, make a for loop, and this for loop will check if every building, when it finds buildings that has flood depths less than 0, make it 0. I find it easier to make it here. So I can do a field calculator and then come here and say that this field is equal to 0. Right now, I'm done with everything. I have a shapefile for this specific scenario that has the building archetype, that has the flood depths measured from the ground elevation, and has the flood depths measured from the verse floor elevation. This is all what you need to run loss analysis using the MATLAB code that you already developed. You don't need anything else. So basically, you will go to your original MATLAB code here, and you already defined all these functions, and you will come over here and just to change the shapefile. Read a different shapefile with the shapefile for the mitigation scenario, and read the field, whatever the field name. You can call it depths FFE, you can call it depths FFE scenario number 9, whatever you want, and you do another one for the ground elevation, another one to extract the archetype, another one to extract the building value, and you run the same analysis. You are not gonna do anything different, just changing, rather than taking the input from the base scenario, take the input from this mitigation scenario and rerun your model. I believe I have this. Let me double check.
So do we have to do more coding for the project?
Not more coding. You're just replacing file's name.
Oh, okay.
So that's what I was saying here. In the same MATLAB code that you have for the calculating the losses, you will just change the name of the file.
To a new file.
Yeah, if you name the same shape, like if you name the same, if you name the flood depths FFE, whatever the same name, you don't have to change these. Okay,
Just a quick file.
just the file name, if you stick with the same names. All right, so.
Where do you start? Where do you start? So the whole 5,000 times 10,000 times first.
Yes.
The same thing, but earlier, but you can do something. You can do it in a different MATLAB file, right?
Yeah.
This is a,
This is something you're reading.
Oh, it's like final replace, that's why.
Yeah, don't worry.
Final replace being the best thing.
It's not it's just.
Oh, nice. Yeah, yeah, but anyways, one by one, I just drop one more thing.
No, I think.
It's not- it won't change, but it won't change.
So let me show you how did I do it. Look at this one. I did all the scenarios on one at a time.
Right.
Look here, I named this like do you remember we extract multi-value points? Actually, you can do it if you want. It's not gonna like take you 1 hour extra or 30 minutes extra. So what I did, do you guys remember when I said extract multi-values to point? And I extracted the flood depths just for scenario number 9. I just put 9 here. So what I did, I put all these scenarios from 0 to 13, and I put them here. And I put the buildings point here. And then I just give them a name like scenario 9, scenario whatever. Let me do it one more time. Here, I just put the building points, and then I selected all the scenarios. And I put all the scenarios here, and I give them a name, scenario number 0, 1, 2. Oh, sorry, is that a shapefile? I put shapefiles, not the rasters. Okay, let me try one more time. What I did here, here's the building shapefile, and I selected all the scenarios from 0 to 13, and I put them here. And then I extracted the flood depths for each scenario. So it generated me raster, my shapefile. I have the archetype. I have the flood depths for scenario 0, 1, 2, 3, 4 until scenario number 13. And I got all of them one at a time in the same shapefile. And then I did some processing on this shapefile, and I got them here. So what I did, I read this shapefile, and I read the VersaFloor elevation of the building archetypes, the building value, and I read the water surface elevation for each one of these from 1 to 13, and also the depths from 1 to 13, all of them. And here, I made few changes because I had archetype 16, which is not there. And then do you remember when I told you if I have the flood depths close and 0, I can do it either in ArcGIS or either in MATLAB? This is what I did here. If the flood depths is less than 0, put it 0. And I calculated all the flood depths here in this for loop. And I run damage analysis, same damage analysis for all these scenarios in the same MATLAB code. This is if you want to do it for all scenarios. But what I want to do, I don't want to confuse you. I'm going to give you one specific hazard, subtract the flood depths for this hazard and the water surface elevation, and do the depth calculation from the ground, from the FFE, and run the same MATLAB code. It's not going to cost you any more time. And then you will see, so when you present your project and you present it in the report, you will show with mitigation, without mitigation, with building level mitigation, with community level mitigation. So you should have in the report 3 main sections. What is the results without mitigation? Without mitigation? What is the result with building level mitigation? And what is the result for each scenario that you have for each building level mitigation and with community level mitigation? All right, so this is the end of the lecture. And so next lecture will be the last lecture. It's not going to be a part of the project. I'm going to introduce a new topic, but it will not add any more tasks to the project. Okay, this is one thing. The second thing, the project presentation is next Monday. So if you don't have, you don't have to have the report. You will have to just present the results. And the report will be due to Wednesday after Monday. Okay, so we have 1 week from now to present the results. All what I want you to present, I want to present to you the hazard maps that I give to you. What kind of, what is the results at the building level without mitigation? What is the results that you have at the building level with mitigation? and what the results that you have at the community level mitigation was the scenario that I'm gonna give to you. So you have 1 week from now to do it. And I'm not asking you to submit anything for this Monday, just show up and do the presentation, and that's it. And then the full submission will be due to the Wednesday after. Okay, does that sounds fair enough? Do you guys have any problem? Okay, so if you have any question, just schedule a Zoom meeting with me, stop by my office, and right now I will be in my office. If you have any question, I'm available until 3, so we can see what problems that you guys have. All right.
We're going to.